Good afternoon and welcome to the Simplify Multi-tenant Microservice Application session. So if I had to guess why you're here today, you're either thinking of building or you are building a multi-tenant and or microservice application. Perhaps you're already using serverless technologies and you're looking for inspiration or best practices around how you would go about implementing multi-tenancy. Or perhaps you're completely new to serverless and you're looking for validation on whether it's even viable to build multi-tenancy using serverless tech. So these are the kinds of questions and themes that we'd like to address for you today. Specifically, we'd like to walk you through a target architecture that's complemented heavily by using serverless technologies. So my name is Anthony and I'm joined here by Ben, and we're both solutions architects from AWS. So in terms of what we have in store for you today, I'm going to start off by giving you a condensed overview of what are the different types of multi-tenancy models and what are the pros and cons of using each. And then we're going to go into our main theme for today, which is using serverless technologies to build the silo multi-tenancy model, or serverless silos for short. And then finally, Ben's going to walk you through a target architecture, and he's going to demonstrate a hands-on approach to implementing serverless silos. So one of the biggest drivers that's brought us towards multi-tenancy to begin with is the software as a service, or SaaS delivery model. And what SaaS essentially boils down to is the idea of designing and building applications in a reusable and shareable way across all of your tenants and customers. So building shareable constructs like identity management, the onboarding experience for your customers, and the operational experience for your staff. And in doing so, you're building towards an operational model that allows you as a product and as a business to grow and scale quickly. So the way that you use multi-tenancy here is going to be key to your success because it's going to influence how quickly you're going to be able to onboard and manage your tenants in your system. But multi-tenancy can be a complicated process to implement, especially if you're operating in a microservice environment where you're potentially multiplying your effort by the number of services that you have. And that's because we're building a set of shared infrastructure, applications, and resources, which means that we need to make a completely new set of considerations. So things like tenant isolation, or how do you ensure that each tenant is prevented from accessing another tenant's data and resources. So it's not uncommon to see here that your only line of defense is the business logic and application code that you implement, which also means that you're potentially one undetected bug away from causing cross-contamination of that data. You also need to think about things like noisy neighbors, or how do you manage and mitigate against the effects of any given tenant who's able to use a disproportionate amount of your system's resources. So if you've ever operated or built a multi-tenant system in the past, then it's more than likely that you've seen this very scenario where any given tenant is able to put so much traffic into the system that they degrade or take down the entire system for your other users. And then finally, you need to think about how you're going to monitor the activity and the consumption into your system per tenant. So how are you going to track the load? How are you going to track the usage metrics? Do you need to introduce things like metering and throttling of your APIs? Or do you need to introduce a completely new subscription model, which allows users that are paying a premium to access more of your resources? So these are among the key considerations that you need to make when you're ultimately deciding on what parts of your infrastructure are going to be shared between your tenants versus what parts are going to be isolated per tenant. So with those in mind, let's talk about what are the two prominent types of multi-tenancy architecture models. So on one end of the spectrum, we have the pool model, which is essentially where we're sharing all of our infrastructure between all of our tenants. So in this example, we have tenants A and B who are accessing the same reverse proxy, same compute, and same database layers. And the main advantage of using a pool model like this one ultimately comes down to cost. So you have the cost efficiencies of being able to run a single set of infrastructure for all of your users, which also means that you're going to get high resource utilization because you get to balance out any of the variability and the consumption and the usage metrics across all of your tenants. And you're also going to find that you get operational efficiencies because you're only having to manage one set of infrastructure. But because everything is now shared, that also means that you need to start handling the challenges of things like noisy neighbors and tenant isolation. And you can do that by using strategies like API throttling, where you're limiting the amount of requests that any given tenant can achieve. You can use things like dynamic IAM policies, where you're enforcing tenant isolation on a resource level. And you can also use things like row level security, where you're scoping the access to each row of a table to only allow certain tenants with their permissions to access it. So you're effectively, again, protecting your data and resources on a resource level. So that's the pool model. You get cost efficiencies, but you also need to make sure that you're managing and protecting your tenants from each other. And then on the other end of the spectrum, we have the silo model. So in this example, we have two tenants who are accessing completely separate sets of infrastructure. And the advantages of running a silo model like this one, as you would imagine, they're inverted to those of the pool model. So in this case, we already have tenant isolation because again, each tenant has their own set of infrastructure. And for the same reason, you're somewhat mitigated against the effects of things like noisy neighbors because all of your tenants can only really negatively influence their own set of infrastructure. You'll also find that the monitoring of activity and consumption between your tenants becomes somewhat straightforward because any one of these resources here can be attributed back to a specific tenant on a one-to-one basis. So creating things like cost and consumption reports for your tenants becomes relatively simplified. But as clean as that sounds, there are reasons why the silo multi-tenancy model isn't always the most practical one to implement. And again, that comes down to cost. So you have the cost of having to run an entire set of infrastructure per tenant, which means that any costs that are associated with each of these resources are going to be multiplied by the number of tenants that you have. And you're also going to incur some operational overhead because again, you're going to be deploying a stack per tenant, which means that you need to multiply your efforts for deploying and managing the lifecycle of all of this infrastructure per tenant as well. But you could argue that a lot of these challenges are more related to running a traditional system using services like EC2 instances and RDS instances. But would the same set of challenges still apply if you were using serverless technologies? And that brings us to the main theme of today, which is, does using serverless technologies make the silo multi-tenancy model a much more viable one than what it was in the past? So let's have a look at a similar architecture diagram, but this time only using serverless technologies. So we have an API gateway for the reverse proxy layer, a Lambda function for the compute, and a DynamoDB table for the database layer. So let's think about some of the tenets and the characteristics of each of these services, which you can also generally apply to serverless as well. So those are things like you don't manage any of the underlying servers, you pay only for what you use. It has built-in high availability, built-in auto scaling, and it also scales on your behalf. So if you think about it, a lot of these characteristics can somewhat address the challenges of operating a silo multi-tenancy model. So for example, you get reduced operational overhead because all of the managing of patching, upgrades, scaling, all of this stuff is abstracted away from you by these services. You'll also find that your running costs are going to become linear because again, you're only going to be paying for what you use. So for example, if we had a tenant that had signed up for your service but never actually accessed the application at all, your infrastructure costs are going to start reflecting that because you only pay for what you use. So at least from a running cost and from an efficiency perspective, serverless technologies are actually a really good fit for implementing a silo multi-tenancy model. But what if we had hundreds or even thousands of new tenants that are constantly signing up for your product? How do you actually go about managing all of this infrastructure? And what are the different considerations that we might need to make? So things like multi-account deployments. There are going to be scenarios where you need to segregate each of your tenants by AWS account because of things like regulatory or compliance reasons, or even to further mitigate against things like noisy neighbors on an account level. You also need to think about how you're going to orchestrate all of this infrastructure. So how do you govern and coordinate all of these deployments? And most importantly, how are you going to think about things like deployment errors and rollback scenarios per tenant? And then finally, you also need to think about the tenant lifecycle management as well. So it's pretty common practice for you to use infrastructure as code and then commit that to your code base in order to standardize all of your infrastructure for all of your tenants. But if your tenants are being dynamically and constantly added into your product, then how do you actually go about making sure that all of your infrastructure is standardized for all of your tenants? So while silo model is much more viable than in the past, thanks to things like serverless technologies, we still have the open question of how do you actually manage all of this infrastructure and how do you bring it together into a single cohesive product? So at this point, I'm going to hand over to Ben, who's going to walk you through a target architecture that sets out to address some of these challenges. Or more specifically, how do you architect a system that allows you to dynamically provision and dynamically manage your tenants in a silo multi-tenancy model?
Thanks, Anthony. All right, so for this session, this section of the session, we're going to be covering the demo portion. So to start off, I'm just going to walk through what does that target state architecture look like, jump into some code examples about how we go about provisioning that with CDK, and then also show an application that's built on top of this demo. So starting off, we have the CI/CD portion of this application. This is a simplified view. You're obviously going to have your full CI/CD pipeline that would sit around this. This could be things like CodeStar if you're using the AWS suite, or a partner offering like GitLab or BuildKite. So that would wrap this whole process. So on the left-hand side, we have AWS CDK. So CDK is the AWS Cloud Development Kit, and it allows you to use familiar programming languages to define what your infrastructure looks like, allowing to use all the functionality of a programming language to dynamically change what actually gets provisioned. Next, we have our CloudFormation templates. So when you use CDK, you actually synthesize CloudFormation templates, so that programming language actually then becomes a template of the infrastructure that gets deployed, and then gets deployed through CloudFormation. In our example, we're not actually going to be directly deploying that through CloudFormation straight away. We're going to be storing all of those templates into S3. This allows us to use CDK to define parameterized templates that we can then populate at deploy time with our tenant information. So they're all sitting on an S3 bucket, ready to go. They can be versioned and managed really nicely. The next section of our architecture is the tenant onboarding. So this is our tenant control plane. And this is the brains of the architecture. So this will manage our tenant lifecycle. So when new tenancies need to be created, updated, deleted, it all happens within this part of the architecture. So our front door for this is a Amazon API gateway. So everything is driven through this gateway. So we'll have a bunch of Lambda functions that hang off that API gateway that will trigger different portions of the application to move. Then we have our Amazon DynamoDB. So in this architecture, DynamoDB is our single source of truth. So this the table within DynamoDB will reflect the state of all tenancies at all times. So whatever DynamoDB says, our full tenant infrastructure will reflect that. So if we've got pooled accounts being deployed or siloed accounts being deployed, that current state of any of those, whether they're provisioning, updating, deleting, will all be stored within that DynamoDB so that we have an easy view to what's happening across all of our tenancies. That DynamoDB has great functionality of streams. So when we see any sort of CRUD operations being performed on that table, we can trigger a stream, which can then trigger any sort of downstream other AWS services. In our case, we'll be triggering Lambda functions and an AWS step function, which will be used to manage the provisioning, updating, deploying of all of our tenancies. So we have a DynamoDB stream that triggers that downstream. And then finally, we have the full picture of what this architecture looks like. So we have our CI/CD portion in the top left there, our control plane in the bottom left, and then we have all of our tenancies that we're deploying. So with this target state architecture, it doesn't care about what does the end deployment look like. It can be pooled within a specific account. It can be siloed within specific accounts. These are all values that you populate at deploy time to get those tenancies out there. So the first portion that we'll jump into to look at some example code is the synthesis of the stacks. So again, that's taking CDK, writing out what does this tenancy look like for each of our tenants, parameterizing those templates, synthesizing CloudFormation template to match that, and then storing that on S3. So jumping into that first bit of code. So this is our first tenant stack that we're deploying. So this would get deployed for each of our tenants through that CloudFormation stack that we synthesize from it. It's been kept short, so there's not a whole lot within here. So you can see we're passing in a couple of parameter IDs, parameters for our tenancies. So we've got a tenant ID, which is unique for each tenant, as well as a tenant name. Then we've got the resources that we're going to deploy for each tenant. So there's a DynamoDB table where we would store tenant-related information, as well as a Lambda function that can perform CRUD operations on that DynamoDB table. In your more complex environments, this function is obviously going to be a lot longer. You're going to have more complex logic, but for the demo, we've just kept it short. And then finally, providing the permissions for that Lambda function to handle that. Then we have our serverless silo stack. So this serverless silo stack is the overarching stack that runs this whole deployment. So it's the top level stack that everything's defined within. So the first thing that we define within this stack on line 20 is that bucket where we'll be deploying those templates. So all those parameterized templates, they're going to be dropped into this bucket. Then what we're going to do is define a stage. So this is where we deviate from the normal way of doing CDK, where we're actually going to define a dummy stage that allows us to synthesize a stack without actually having to do a deploy to generate that CloudFormation template. So I'm just defining a new stage here, which is my synth stage, which I'll then pass into my tenant stack. So this is the tenant stack that we just went through before. And you can see that we're passing in that stage, which is that synth stage. And then we've got an interesting step, which you don't normally have exposed. So by default, when you're deploying a new tenant stack, you're using the default synthesizer. And that's just, you wouldn't see that being deployed here. But in our case, we're actually using the bootstrapless synthesizer. So what the bootstrapless synthesizer allows you to do is to generate a CloudFormation ready template that can have parameterized values, and it doesn't need to know what account am I going into, what environment, what region. All of that can be filled out at deploy time. So using the bootstrapless synthesizer, you can generate CloudFormation templates ahead of time. Then we just force a synthesis of that stage, and what this will do is generate those local assets for those CloudFormation templates. You can traverse the path to find out what was that template path name, so I know locally where has CDK synthesized those templates to, and then I can push that on line 41, I can push that into a bucket deployment. This bucket deployment is just a construct that will grab whatever artifact you're passing in, so in my case, that source is that template full path, and then a destination bucket, and all that's going to do is it's going to sync that information up to S3. So those templates are just going to get pushed up. And then the last step in this stack is defining the control plane stack. So that's the next stack that we'll jump into, but that's the brains of the operation. And so that all that we're passing in here is, here's the bucket that we just created, and here's the name of that specific template that we've just created. Again, in more complex environments, you might look at passing in versioning or different customer mappings, just simple for this. Jumping back to our presentation. We have the tenant onboarding portion of the stack. So again, API gateway, that's our entry point. We have our tenant onboarding Lambda function. So this Lambda function will receive all of the tenant information coming from the front end or whoever's hitting that API. And this will pass in our example, tenant ID, the deployment type, is it a pool tenant, a siloed tenant, as well as any other necessary information that's required for new tenant onboarding. This information gets written into a DynamoDB by that Lambda function. And then off the back of that, we can trigger a step flow workflow orchestration to manage the onboarding of that tenant. Using step functions allows us to utilize the really nice error handling retries that comes with step functions, so we can manage all of that. We won't dive into that in the code because we're just trying to get through all the content that we need to get to. Jumping back into our code. So the first thing that we're defining is our Lambda function for our tenant creation. Normal Lambda function we have here, we're passing in that table that is that single source of truth for all of our tenancies, providing access to that, and then finally we're just adding an integration for API gateway. So just attaching that Lambda function to our API, adding it on a /onboarding path, and it uses a post method so that we can post any tenant information to it. Next, we have our provisioning event. So the first thing that we need to do, as the Lambda function will call CloudFormation, we need to provide a role to CloudFormation to actually use for the deploying of our infrastructure. So that's what I'm defining here is what does that role look like? I give it access to the service principal for CloudFormation, and then we create a policy to allow it to do the deployments. This is obviously a permissive policy. You can see we've got a bunch of wildcards here. Do not do this in production. Make sure that you fine-grain scope all of your permissions so that you only need to deploy exactly the resources into the exact account and environment that it needs to go into. For demo's sake, we've just wildcarded it. Attach those permissions there. Then we have our Lambda function. So in our Lambda function, we're passing in a couple things. Our DynamoDB table that has all of our tenancies, that bucket where our template is stored, the key template, so that's the key, the bucket key for that template that we created, and finally the role ARN so that we can do a pass role to CloudFormation to make that deploy. Provided permissions to create the stack. Again, pretty open policy. Don't do this in production. Providing all of the permissions, skipping through that. And then we get to the event sourcing portion of this. So we're going to use a Lambda event source mapping here, which allows us to attach a target of that Lambda function that we just defined. We have an event source ARN, which is our DynamoDB table stream ARN. We have a starting position, so this will just be every new event that comes through is going to trigger our Lambda function. But you'll notice there's going to be an issue with this. This will trigger every single time there's any CRUD operation on a DynamoDB table. So if I went to delete a tenancy, that's actually going to start kicking off provisioning another tenancy. And this can be some of the gotchas with using different levels of constructs within CDK. So for those that aren't aware, CDK has different levels of constructs. So you have an L1 construct or a CFN construct, which is a direct one-to-one mapping between a CloudFormation resource. So every single property you need to pass into CloudFormation is required for you to pass that in for CDK. Then you have layer 2 constructs, which is a construct that we've used here, which use an intent-based API and are going to have a lot of same defaults put in, boilerplate, some glue logic. So all the defaults that you would normally put in, they're all going to be done for you. It's going to be abstracted away. So what that means is you can quickly, in a couple of lines, define something and not have to deal with a lot of the grunt work, but you also have a little bit less visibility into that. And then finally, you have layer 3 constructs, which are patterns, and patterns are generally one or more services working together to perform like an ordinary thing. So like there's functions like the AWS API Lambda construct, which is a API gateway backed by a Lambda function, and you do that in like 3 lines of code. So the constructs make it easy to do things, but they can also hide some things away. So that's where in CDK, there's something known as an escape hatch. So an escape hatch allows you to take an L2 or an L3 construct and kind of jump out in and get back to that L1 construct. So you can traverse your node and actually get the underlying L1 construct. So I can get back to my CloudFormation event source mapping L1 construct and actually modify that underlying construct if I need to be. So that means I can use all the niceties of an L2 construct, but if there's little things I need to adjust on an L1, I can jump out and do that. And the reason I've done that is so I can do a property override for the filter criteria and add a pattern match for event names of insert. So now when I deploy this, it's only going to kick off that stream event when it sees a new insert event coming in. Then we can jump back into our presentation. And then, so our last part, we'll skip past the step flows. So that's just the full orchestration of the whole thing. But we have our Lambda function that will manage the onboarding. So from S3, we'll retrieve our templates, hydrate the templates with all of the parameters that we've defined, and then call CloudFormation to actually manage the deployment of that tenant infrastructure into pooled or siloed accounts. Back into the code. So we have our provisioning Lambda function. Couple quick things at the top. So tables being passed in, the bucket name, the key template, that role ARN. Then we're going to retrieve that template from S3, read it in, so that it's ready to be cast to CloudFormation. With the event streams that come from DynamoDB, you may get one or more, so just make sure you iterate across all the records that you receive. I'm going to do a check here just to make sure that this tenancy is ready to be provisioned. So I make sure at every single step I update the state of the tenancy. So if a tenant comes in a provisioning state, it's not ready to, or it's currently provisioning. If it comes in initiating, I know it's ready to start provisioning. So if it passes that check, then I'll update that state to it now being provisioning, and then kick off the actual creation of that stack. So I pass in the params. So CloudFormation expects specific key value pairs for your params as you're passing them in. So I just massage them into that format it expects, and then I call CloudFormation to do that actual deploy. So do that create stack, pass in a specific tenant name that I'm providing, that file content, so that S3 template that we read in, that params dictionary that I've just created there, and then finally the role ARN that we're going to do a pass role to. And that's it for the Lambda provisioning portion of the stack. We then have our Lambda onboarding portion. So this is what gets kicked off the back of that DynamoDB stream. So this will read in the values that we're getting passed in. So like the body from the API gateway as that's coming in. Sorry, this is a bit out of order. So this is the initial onboarding portion that comes in. So when I make that request to the API, this is where we just grab all that tenant information, generate a tenant UID, timestamp the creation time, and then push that value into DynamoDB. So now Dynamo is aware we have a new tenant that's going to be onboarding, and then off the back of this insert, it will then kick off that stream. So the really nice thing about all of this being built on top of one DynamoDB, so we have a single source of truth, and 2 API gateway, is that you can build interfaces on top of it. So I've built a absolutely beautiful interface that sits on top of this, and this allows me to manage all of my tenancies from a single point. So you can see currently I've got 2 tenants that have been deployed, one in the pool side, one in the silo side, just named pool 1 and silo 1. So I can jump in here and have a look at what's been deployed for each tenant, give that a second to load. I might need to reopen it. Sometimes there you go. So that just made a query to DynamoDB and said like what's been deployed for this specific tenant. So I can see I've got a Lambda function, DynamoDB table, and some metadata. So that matches that tenant template that I was showing before. So then what I can do is I can actually deploy a new tenancy. So I put in the name of my tenancy. This one's going to be a pool, and I'm going to click create on that. And there you go. So that's now pushed that in. So this reflects the actual state. You'll see that just changed from initiated to provisioning. So that's already gone to CloudFormation, and it's already deploying all of that tenant infrastructure. As it's all serverless infrastructure that's being deployed from this, and it's not a massive amount that I'm deploying for this demo, it deploys pretty quickly. So at the same time, how do I spell silo? There you go. I'll deploy a new solid one, and I can see that actually before I've been able to deploy another one, that pool has already been deployed. So that tenant infrastructure is all up and running. So if I wanted, I can start querying that underlying database, hit that Lambda function, it's all good to go. And my silo 2, that's in a provisioning state, and it will swap over. At the same time, from the same interface, I've added a delete option. So I can then start deleting that infrastructure, and there you go. So it's going to go into that deletion state. And so from this little front end, every 5 seconds, it's just hitting a get tenants API that just returns what is the current state of all of my tenancies across the board. So that one's in a deleting state. This Silo 2 model, that one's now running. That's good to go. And I think the deletion takes probably 10 more seconds, and it'll drop out that pool 1. So that's a nice advantage of if you have people that don't want to be hitting the APIs directly or going into AWS console, is that you can build on top of that to provide an interface to allow really anyone to be able to manage the tenant onboarding and offboarding. And again, as it's all API driven, you don't even need this interface. You can just have, when a tenant signs up on your website, it kicks off this whole flow for you. And I can see there that that pool has now disappeared and that infrastructure is now gone. And I'll hand back over to Anthony for the wrap up.
Thank you, Ben. So before we wrap up, just a quick recap of what we covered today. So we talked about the pool versus the silo multi-tenancy models, where the pool model gives you better cost efficiencies, whereas the silo model gives you better tenant isolation. We then walked through the concept of serverless silos, where you're effectively trying to get a combination of both cost efficiencies and tenant isolation. And then Ben just walked you through a target architecture that sets out to address some of the challenges of working with serverless silos. And of course, that was only one of many different solutions and tools that you can use to implement your own. But the idea was to get you thinking about what are the different challenges, what are the different trade-off decisions that you need to make when you're designing your own multi-tenant systems. So if you're looking to get started on your multi-tenancy journey, I'd recommend checking out some of these resources. We have the well-architected framework SaaS Lens, and that can help you make a current assessment of how you approach multi-tenancy and SaaS in general. We also have the serverless SaaS reference solution, and that's available in GitHub. So that has a collection of different sample code that addresses a lot of the common SaaS functionality. And down the bottom there, we also have the blog post that describes a pretty similar implementation to the one that you just saw today, and that uses technology like CDK as well. We also have a range of resources available in skillbuilder.aws, so please make sure to check those out too. So on behalf of Ben and myself, thank you for your time today. We hope you're able to take something away. Thank you.